Okay, so again, so let's start na, no? So last time, we were able to solve for the equilibrium concentration of our chemical species with the help of the ice table. Okay, so what's the purpose of ice table? The ice table will allow us to track the changes of our chemical species as it achieves equilibrium, no? So ano nangyayari do'n, yung ibang reactants nako-convert into products by this much, no, by X, no. So in the ice table, pinapakita natin yon mathematically, okay? So the I for the ice table stands for the initial concentration, the C stands for the changes in the concentration, and the E stands for the equilibrium concentration expression. Okay? So yung I, initial concentration, that's usually given sa problem. If it is not given, then the initial concentration is equal to 0. For the C, the change, no, we can determine which side of the reaction will increase or decrease by comparing your Q value with the K, no. So if your Q is less than the K, that means the reaction is going to the product side, no? So the change for the product side is positive, but for the reactant side, that's negative. If your Q is greater than K, then your reaction will proceed towards the reactant side. So the change for the reactant side will be positive and for the product side, negative. And another way para mapabilis yan is tignan mo na lang kung nasaan yung zero. Okay? Kung nasa zero, kung yung sa product side, dun may zero, then the reaction is going to that side. If sa reactant side may zero, then the reaction is going to the left side. Okay? Also, the change is stoichiometrically governed, no? So, ibig sabihin, it follows the law of conservation of mass, basically stoic. So, that means if we have coefficients, we have to multiply it as a change, no? So, kunwari, we have 2 moles of this species, then 2x yung change sa kanya, positive or negative, no? Kunwari, we have 3 moles of this other species, then the change is 3x for that, no? So it could be positive or negative, no? Depending on the direction of your reaction. And then after obtaining the C, you get the E, the equilibrium. You just add the I and the C to get the E expression with X now. Then yung mga E expressions mo na yun, you will plug it in your Ka or Kb. So plug in mo siya sa equilibrium constant mo, and then you later on solve for the value of X. Then once you were able to solve for the value of X, you can now determine the equilibrium concentration by replugging it to the equilibrium concentration expression. So ganun yung mga ginawa natin last time. So for our discussion today, I will teach you the approximation technique. Okay? So this is also called the small x approximation. So according to the small x approximation, if the concentration of your reactant divided by the equilibrium constant is greater than or equal to 1000, then you can assume that the x is small. When we assume that x is small, we don't need to use quadratic equation na. Okay? So pwede mo itanggalin mo na yung x para hindi ka na mag-quadratic equation. Okay? So the calculation will be very much simplified, no? So instead of us answering the problem for around 5 to 10 minutes, mare-reduce na siya into ilang minutes na lang, no? Okay? Then kapag gamay nyo to, within 1 minute, kaya nyo masagutan yung isang item. Legit, no? Pero in your case, let's say minimum na yung 3 minutes to answer problems like this. Yun yung basis ko bakit iba-iba yung time sa assessments nyo. Okay? Pag nasagutan ko 1 minute, 3 minutes sa inyo. Okay? Pag nasagutan ko 5 minutes, 15 minutes sa inyo. Okay? So, ganun. However, if your problem doesn't satisfy the criteria for the small x approximation, you need to use the quadratic formula. Okay? So, no choice kapag ganun. Okay? So, again, ano yung criteria for the small x approximation? The concentration of reactant divided by K is greater than or equal to 1000. Pag na-meet natin to, we can use the small x approximation, meaning no more quadratic equation. Pag hindi yan na-meet, magkwa-quadratic tayo. No choice. So, we had the same problem last time. Ang value ng x natin dito ay 0.029. So let's try to check whether we can use the small x approximation here or not. So, yung process ay the same pa rin. You write the ice table, you write the equilibrium constant. Sulat ko uli yung info natin. So initially, we have 120 molar of nitrous acid, 0 for the products. This is negative x, positive x, positive x. We have 1.20 minus x, x, then another x. Now, still same process pa rin like last time. Okay, then you write the K value. That's the concentration of acid, concentration of nitrite ion divided by the concentration of your HNO2. Kasi pa-plug in mo yung E dito sa K. Plug in natin. So you have your Ka equals x times another x divided by 1.2 minus x. Okay? So, typical steps. Saan papasok yung small x approximation? The small x approximation can be done here sa denominator. Ito yung reason kasi why we do quadratic equation. Yun nasa denominator. If we distribute Ka sa x, then we will have the x term for the quadratic equation. Diba? X squared plus bx plus c yan. Because of the presence of the x term in the denominator, we need to use quadratic equation to solve for the value of x. But, if we assume that x is small, ibig sabihin, negligible yung x value natin. Ibig sabihin, pwede na i-disregard. If we disregard this x value on the denominator, mawawala na yung bx term sa quadratic equation. So, buburahin na natin yan. You will be left with x squared and the constant. Square root lang yan para makuha mo yung x, di ba? Okay? So, yun yung purpose ng small x approximation. To eliminate the x value, okay, that is present in your denominator. So, ganun lang gagawin natin. So, paano natin malalaman if we can remove the x in the denominator or hindi pwede? Para malaman mo kung pwede mo yan burahin, you need to use the ratio kanina. So let's try to determine if the concentration of your reactant, in this case nitrous acid, if we divide that by the constant Ka, is that greater than 1,000 or equal to 1,000? Tignan natin. By the way, may correction nga pala sa Ka value tayo na. Hanapin ko lang yung correct Ka value. That's 4.5 times 10 raised to negative 4. 4.5 times 10 raised to negative 4. So, gawin natin. Let's divide the concentration with the K value and check if that is greater than 1,000. So, we have 1.2 molar for the concentration of the acid. Ka is 4.5 times 10 raised to negative 4. Divide natin yan. Calcu. So that's 2,666, which is greater than 1,000. If the ratio is greater than 1,000, then you can use the small x approximation. Okay? Again, kapag dinivide mo itong concentration by the Ka and greater than 1,000 yung ratio nila, you can use the small x approximation. Pag hindi, edi hindi. Na. So, since pwede tayo mag-small x approximation, ano gagawin natin? Diba, dito may Ka tayo. When I say we can use the small x approximation, we can just remove this x term. Pwede na natin burahin yan. Okay? Yun yung meaning ng small x. Negligible na yung x value na yun. So, ibig sabihin, we can just simply erase that. So, our equation will be reduced to this, no? X squared Ka, then the concentration of your acid. Wala na yung minus x. So, we can rewrite this in terms of x. So, we get x squared equals 1.2 times the Ka, or x equals the square root of 1.2 times the Ka. The x value is 0.023. Di ba ito din yung na-solve last time? No? If you check your notes, yan din yung x value natin. Okay? So, that is how small x approximation, no? So, ganyan siya mag-work. Okay? So, again, we still ended up with the x value na nakuha natin last time. Pero shortcut na. Instead of doing quadratic equation, we skip that part na, no? So, ginawa lang natin, we just obtained the square root of the concentration of the acid and the Ka. Kaya ang tawag namin dito ay square root of Chaka. Bakit square root of Chaka? 1.2 is the concentration of your acid times the Ka. Chaka, di ba? So, you just get the square root of Chaka to get the x value. Okay? Mas madali na siya kabisaduhin kasi isipin mo na lang, tsaka yan, no? Kunin mo lang square root ng tsaka. You have your x value. Easy lang, no? However, itong mnemonic ko na to, mnemonic namin na tsaka, that will only work if the coefficients is 1, no? Kapag ang coefficient natin ay 1 lang. Pero kunwari may 2 yan, may 3, hindi nagagana yung square root of tsaka na mnemonic. Okay? So, ito yung sinasabi ko last time sa inyo. Bakit pwede ma-solve yung concentration ng x with square root of Chaka? That's the small x approximation. Okay, so check nyo yung notes nyo last time. Same x value pa rin yung nakuha natin. Diba? So, yan. Yan yung square root of Chaka or the small x approximation. And hindi dyan natatapos yung x, no? Hindi tayo natatapos sa pag-solve ng x. Dito tayo matatapos when we determine the actual equilibrium concentrations. You plug in the x values. So this will be 0.023, and for the nitrous acid, that will be 1.177. Diba ito din yung na-solve natin last time. If not exactly near that, yung sagot natin last time. Okay? So, yan. By the way, correction natin. Baka kasi isipin nyo, since binura ko yung x dito, buburahin ko rin yung x dyan. No. We only remove the x here because of the approximation. Pero it doesn't tell you na ito ay buburahin mo rin. Yung nasa ice table yan, as is yan. Okay? Wala kang babaguhin dyan. Only in your solving part, no, sa determination ng x value lang. Okay? So that's how this problem can be solved, no, using the technique. Okay, so again, recall, you create your ice table, you write your K expression, and then you divide the initial concentration of your acid by the constant. If the ratio is greater than 1,000, then you can use the small x approximation. Anong gagawin nyo? On your denominator, yung minus x term doon, pwede mo na siya burahin. Okay? So that you will no longer use the quadratic equation. Wag ka na gumamit ng quadratic equation. Because the x can be determined by the square root of Chaka. The concentration of acid times the Ka, square root mo yon, x na yon. Then whatever your x value is, i-plug in nyo uli yun dito to get the actual equilibrium amounts. Yan, tapos na. So, ito yung reason bakit 1 minute lang kaya sagutan yung isang problem. Okay. Actually, kapag nasanay na kayo, no, kahit di na kayo mag-ice table, magbe-mental-mental na lang kayo. Kaya yan. Although, if you want to be very sure, you have to write the ice table. Okay. So, medyo important tong technique na to because in your midterm examination and yung quiz dito, sandamukal na questions na ganito yung ibibigay ko sa inyo. Pero, yun. Kailangan alam nyo kung pwede siya gamitan ng technique or not. Kasi kung hindi nyo gagamitan ng technique yan, ang tagal nyo matatapos. Okay? So, yun. So, that's how square root of Chaka works. Now, let's try another problem. So let's try this problem. Calculate the equilibrium hydroxide concentration from 0.075 molar ammonia. So ito ay ammonia. So base to. So base. Okay. So Kb meron tayo. So ito ay typo Kb yan. Hindi siya Ka. Kb yan. Okay. So we have the Kb. Ano gagawin natin? You construct the usual ice table. No? Construct natin lahat. No? Pati yung Kb expression. Okay? So, sulat mo muna ito. Mag-proceed ka lang as is. Ha? Sabi sa problem, initial concentration of ammonia is 0.075. Then, wala for the products. Okay, so since wala sa product, positive X doon, and negative X for the reactant. So the equilibrium expression is 0.075 minus X, X, and another X. Or you write the Kb. Kb is equal to the concentration of ammonium ion, OH, divided by ammonia. Okay. And then we plug in the equilibrium expressions. So that will be X times another X. And then for the denominator, we have 0. Okay, so for the denominator, we have 0.075 minus X. Kapag hindi natin natanggal tong X na to, this will give us the Bx term sa quadratic equation. You multiply Kb with the X, Bx yun na. So we have the quadratic equation na. So kapag hindi mo binura tong X na to, you will need to use quadratic equation kasi important yung Bx. But if we can apply the small x approximation, we can just remove this. Ang answer for x, pwede mo na siya makuha using square root na lang. Question, can we use the small x approximation here or not? Paano natin malalaman kung pwede? You get the ratio of your reactant with the K. So, kunin mo yung ratio ng reactant with the K. So, divide this by that. Ba't nalilipat ng kabilang slide? Excited yung PowerPoint. Okay, so divide natin ito by the Kb. So, Cb divided by Kb. B kasi base na, no? Base kasi meron tayo eh. Pero kapag acid yan, Chap, no? CHA, acid yon. So, this is 0.075 molar divided by 1.75 times 10 raised to negative 5. What's the ratio? So the ratio is 4,000. 4,285 na. 4K na lang. So that's greater than the threshold na 1,000. So that means we can use the small x approximation. Okay? So ibig sabihin nun, the x on your denominator can be removed na. Pwede na natin siya burahin. Okay? So burahin na natin siya. So now we will solve for x. Okay? So i-rearrange natin tong equation na to. So we will get x squared equals 0.075 kb. To get x, that is the square root of CB KB, the concentration of base times the KB. Okay? So again, kapag base yan, CB KB. Kapag acid yan, tsaka. Okay? Again, kapag acid, x is square root of tsaka. Kapag base, x is equals to square root of CB KB. Okay? So solve for x. We get the square root of 0.075 times the KB. 175 times 10 raised to negative 5. X is 1.15 times 10 raised to negative 3. So yun yung x values natin. Let's plug it here. 1.15 times 10 raised to negative 3 rather. Negative 3 molar. That's also 115 times 10 raised to negative 3 molar. And ito, yung ammonia, that will be 0.0739. Yan yung kanyang final concentration. Okay? So, yan. So, with the help of the small x approximation, we can eliminate the need of using quadratic equation. Hindi na natin siya kailangan. Again, kailan pwede gamitin ang small x approximation if the ratio of your reactant concentration divided by your K is greater than 1,000. Greater than or equal to 1,000. So, doon ka lang pwede gumamit ng small x approximation. Again, when I say small x approximation, yung minus x sa denominator, buburahin mo na siya. Okay? So, yan. You can double check it if, gagamitan mo to ng quadratic equation. So, I will not do that anymore. Kasi, okay na yan. Okay? So, kung gusto niyo lang i-double check na same sila ng answer, you can try, i-quadratic nyo na lang to after the class. You will end up with the similar answer. Similar, bakit? Kasi may mga round off tayong ginawa eh. Okay? So, pero the idea is almost the same sila. Okay? So, that's how small x approximation works. Let's try this problem. Pag hindi to pasok sa small x approximation, hindi ko na gagawin. Okay, na bahala doon. Okay? Para ma-practice kayo. Okay, so let's check this out. Tignan natin kung pwede dito yung small x approximation. You divide the concentration of your acid with the Ka. So, divide natin. Ito yung concentration ng acid natin. Times 10 raised to negative 4 divided by your Ka. The concentration of acid divided by Ka. Tignan natin yung ratio nila. Hindi ko nasasagutan yan kasi since 8 yung ratio nila, we cannot use the small x approximation. Okay? So, hindi mo pwede na gamitin yung small x approximation dito. So, kayo na bahala dyan. Magsagot. And don't worry, the answer will be posted naman together with the other problems na may solution. Bibigay ko yan next week, no? Para may time kayo to review for your midterms, which is next week na. Okay? So, ganun lang. Pag may question, don't hesitate to ask. So that's the technique, no? So hopefully ma-grasp nyo yung idea. Kasi this is very useful. Share ko lang, no, nag-boards kami. Ang daming ganitong questions. As in, super dami. Since naalala ko yung square root of tsaka, maaga ko siya natapos, no? As in, dun sa kwarto. Isa ako sa unang natapos. Tapos yung iba hindi pa rin. Tutulog ka na lang muna. Tapos pagkagising mo, hindi pa rin sila tapos. Ganun ka-helpful yung mga techniques na to. Okay? Lalo na sa midterm, no? I don't think na tinuturo to ng iba. So, kung hindi tinuro ng iba, may advantage kayo. Mabilis kayo matatapos sa exam. So, you will have more time to double check your answers. Okay? So, next one, let's proceed to the percent ionization. Remember, for strong acids or strong bases, the ionization is 100%. No? So, if you have a strong electrolyte, the ionization of your species is 100%. They are all converted to products. However, if you have a weak electrolyte, the percent ionization is less than 100 because our species come to equilibrium. No? So, nag-equilibrate kasi sila. That's why we have less than 100% ionization for weak electrolytes or weak acid, weak bases. If you want to determine the percent ionization of your species, all you have to do is to divide the product concentration by the initial concentration. Okay. For acids, that's the concentration of your hydronium ion divided by the initial concentration of your acid. Okay? So, for acids yon, concentration ng H plus divided by the acid initial concentration, the HA. Pag bases, usually yung products, no, yung hydroxides, although that's uncommon. Commonly ginagamit ng percent ionization with acids. No? So one example would be yung suka sa bahay. We know that our vinegar is composed of acetic acid. The percent ionization of acetic acid for household products, that is limited to 5% lang. Okay? So 5% lang ng asim yung nandun. So imagine nyo kapag mataas yung percent ionization nun, no? Gano'n kaya ka-asim yung suka natin in just in case, no? Mataas doon. Okay? Ibig sabihin 5% pa lang ng asim yung natitikman nyo dun sa suka. May asim pa yan. Okay? So, ganun lang. So, let's try to answer this problem. So, we have this suka, acetic acid, CH3COOH. Let us determine the pH and the percent ionization of the suka. Ang problem ko lang dito is hindi ko nabigay yung concentration. Kalimutan ko i-type. So, let's assume that the initial concentration of vinegar is 0.05 molar. Okay. In case na walang binigay sa inyong equation, you have to write your own equation for the acetic acid. Okay. How do we write the dissociation of the acetic acid into its ions? So that can be written as CH3COOH plus water. So aqueous yan. Plus water, it will produce H3O plus AQ plus CH3COO minus aqueous as well. So that is one way of writing this equation. Pwede rin naman yung ganito lang, CH3COOH aqueous that will equilibrate to H plus aqueous and CH3COO minus aqueous. Any of the two will work, no? But the acceptable version is the one written above, no? Ito talaga yung proper way of writing that. Kasi makikita mo ito yung acid, ito yung base, ito yung conjugate acid, ito yung conjugate base. Okay. However, pwede naman natin i-shortcut as ganito. Okay lang yan. Walang problema doon. So, I will use this equation below para masulat natin yung ice table. Ay, yung equation na lang sa top kasi yun yung mas acceptable para masanay din tayo. Para masanay tayo yung nasa taas na sinulat ko kanina yung lalagay ko. Plus water. Water will serve as our base. They will produce H3O plus hydronium ion and acetate ion. Lagay mo sa ice table yung aqueous species. Always yung water liquid yon. So, hindi mo siya ilalagay talaga. So, lagay natin yung species natin sa ice table. Okay, so yan. Then, plug in mo yung mga info, complete mo yung ice table. So, here we have 0.5 molar of the acetic acid. And nothing was said about the products, so 0. So, since 0 yung ating products, positive change for them, and negative change for the reactant. Take note of the coefficients. No? And at equilibrium, we're just going to add I and the C. Wait lang. We have 0.05 minus x. This is x and another x. Then you plug this into your K expression. K is equals to Ka in our case. That's the concentration of your products over the reactants. Then you will plug in your equilibrium expressions. Okay, plug in lang. This will be x and another x, so that will be x squared. For the numerator, and for the denominator, you have 0.05 minus x. You can proceed with quadratic equation, but since we already know the technique, let's try if kaya dito. So alamin natin if we can use the technique. Paano? You divide the concentration of your acid by the Ka. You just divide them. So that's Chap over Ka. Okay. That is 0.05 divided by Ka. So tignan natin kung yan ay greater than 1,000. Pag greater than 1,000, mag small x na lang tayo para hindi na tayo mahirapan. Greater than 1,000. So this is 2777 ... Okay. So the ratio is greater than 1,000. So we can use the small x approximation. So in doing small x approximation, ano gagawin? Burahin ko muna to. So we can just simply erase this x part here sa baba. Okay? So yan, small x approximation na tayo. So we can get x by the square root of Chaka. Okay? 0.05 Ka. Diba? Easy. Solve for x. Square root of Chaka. Pag nakalimutan yung square root of Chaka, hindi, wag na. Baka magalit kayo sa joke. Isipin nyo na lang yung friend nyo. Yun yung equation. So that will be 9.48, 49 na lang, times 10 raised to negative 4 molar. Ayan. Huwag nyo kalimutan square root of Chaka. Pag pwede gamitin, gamitin. Huwag nyo napahirapan sarili nyo, please. No? Okay? So, yan. So, that's the x value. Ano na gagawin natin? Plug in. Paki-plug in na lang. Plug in natin. So, the x values is H3O plus is 9.49 times 10 raised to negative 4. And then for the x here, sa acetic acid, that will be 0. Ay, ano nangyari? Ayan. So that will be 0.049. Diba? Very small lang yung change sa x. No? So, yan. Baka kasi kapag nanood kayo ng iba kong video, no, napanood nyo sa section 2. Sa section 2 kasi ang ginawa ko 0.5, sa inyo 0.05, no. So magkaiba yung equilibrium values na nakuha natin. Kasi magkaiba to. Okay, so ganun. Tapos kunwari napanood nyo sa section 6, iba na naman ibibigay kong concentration. Para iba-iba, para masanay tayo. Okay? So, yan. So, these are our equilibrium concentrations na. How about the pH? Yan yung tinatanong eh. When we say pH, this corresponds to the equilibrium H3O concentration or H plus concentration. Again, the pH corresponds to the equilibrium concentration of your H plus. Hindi yan yung sa acid, sa H plus. Magkaiba yung acid sa H plus, ha? Okay? So, ganun. So, when you say pH, equilibrium concentration ng H plus. So, ito yung gagamitin natin, itong 9.49 times 10 raised to negative 4. Well, let's get the pH. That's negative log of H plus concentration at equilibrium. Emphasize ko yon. Baka makalimutan at equilibrium. So, pH is, pakipindot na lang, 9.49 times 10 negative 4. pH is 3. Okay? 3.02. Sige, 3.02. That is the pH of our acetic acid solution whose concentration is 0.05. Diba? Again, take note. When we say pH, equilibrium H plus concentration yan. Not the acid concentration. Ha? Paki-take note ha. Baka kasi mamaya makalimutan. Equilibrium yan. How about the percent ionization? For the percent ionization, dito na lang ako magsusulat. So for percent ionization, that is the concentration of H plus divided by your initial concentration of the acid times 100%. So percent ionization, percent I na lang. That will be the concentration of H plus, 9.49, divided by the initial concentration of your acid, 0.05, times 100. So percent in ionization is equal to that's equal to 1.898%, or we can just say 1.9%. So it dissociated by 1% lang. Okay, so yan, ganyan magsagot ng problem. Di ba napansin nyo, ang bilis natin natapos because of the small x approximation. So if hindi tayo nag-small x approximation, most likely nagsosolve pa rin tayo ng x value. Okay, so yan. So I hope na naunawaan yung small x approximation, kailan siya pwede gamitin, at pag ginamit siya, ano yung buburahin, yun nasa denominator. Then to get the x, that's just square root of Chaka for acid or square root of CBKB for the base. Concentration base, K ng base. No? Yung Chaka, meaning non, concentration of acid, Ka. So, ganun. So, pagkabisado nyo na yon, madali na lang mag-solve ng equilibrium. You will be able to accomplish one item in just, let's say, 3 minutes. No? Siyempre, babasahin nyo pa yan, tapos kakabahan pa kayo. No? Or hopefully, pag nag-quiz kayo, keep in mind lang, square root of Chaka, that is square root of CBKB. Okay? So, yun. Pero kung if this problem doesn't qualify doon sa technique, no choice kayo, magko-quadratic kayo. Gamit kayo ng calculator o kaya ng symbol lab para mabilis mag-solve ng x. No? Pero I suggest calculator ang gamitin nyo. Kasi Maraming wonders ang calculator na hindi nyo pa nalalaman. Okay. Ang daming pwede gawin sa calcu na yan. Okay. So, yan lang. Let's have this problem. Calculate the Ka and the percent ionization of an acid HA given that 0.7 molar of HA has a pH of 4. Ito ay medyo, sabihin natin, medium pa lang yung difficulty nito. Medium pa lang yan. Yung kanina mga easy lang yan. Ito medium na. Kasi mapapaisip talaga tayo dito. So, in our problem, we have an arbitrary acid, HA. So, HA lang daw yan. So, ipakita natin kung paano mag-ionize yung HA. Given na yan sa previous slides. So, we show the ionization of our arbitrary acid, HA, as ganito. It reacts with water to produce H3O+. And its conjugate base, A-. Ayan, nandun yan sa previous slides, di ba? Kung naaalala nyo. So, yan. Yung HA arbitrary acid yan. Pag tinamad kami mag-isip, HA na lang. Okay? So, yan. So, this is the equilibrium equation for the ionization of HA. Let's try to construct the ice table from this. No? Every time you have an equilibrium expression, you try to write the ice table parate. Sulat mo parate kung ano yung info sa ice. No? So you have HA for the reactant, H3O+, and A- for the products. Initial concentration, 0.7 molar for the acid, 0 for the products. So since 0 yung products, positive yung change dito, and negative for the reactants. O you combine I and the C. Okay, nagulo lang. Pagsamahin sila. Okay, then mag-isip tayo. Sabi, hanapin ko daw yung Ka. Sige. So, Ka equals concentration of H3O+, A- divided by HA. Ang problema natin, yung concentrations natin ay X. Kasi yung Ka, hindi mo pa alam. Ibig sabihin, hindi natin masasagot tong problem na to. Masasagot natin to. Okay. Basahin pa natin maigi. So, ito yung ice table, ito yung K expression. Ano kaya dyan sa problem yung magbibigay sa atin ng hint para masagutan tong question na to? Anyone? Alin kaya dito sa sentence na to yung magbibigay para masagutan ito?
Sir, yung ano po, yung pH po.
Yung pH. Ano yung saan siya corresponding yung pH?
Doon po sa may H3O+, pati sa may conjugate po na base.
Yun. So, yung pH, sabi ko kanina, kaya in-emphasize ko talaga siya ng malala. No? Sabi ko, yung pH, this is the equilibrium concentration of H3O. Okay, so thank you, Levin. So, this is the equilibrium concentration of the H3O. No? So, alamin mo lang, ano yung concentration ng H plus dito from the pH? Yun yung X value mo sa H3O. And since yung ating conjugate base, X din. So, kung ano yung concentration ng acid ay ng H+, yun din yung concentration ng H-. And since you already know the concentration, yung X, pwede mo rin yun i-plug in dito sa HA. Okay? So, ganun lang. And just look at your problem. Hanapin kung sino yung magbibigay ng clue kung alin dito yung known na. No? Bukod sa initial amount. Okay? So, kunin natin yung H plus from the pH. No? So, pH is equals to negative log H plus. To get H plus, we just get the antilog of the pH. That's 10 raised to negative pH or 10 raised to negative 4. So, H plus at equilibrium is 10 raised to negative 4. So that means X is 10 raised to negative 4. Ito rin, 10 raised to negative 4. And at the same time, HA is now 0.7 minus 10 raised to negative 4. Yan yung kanilang corresponding equilibrium concentrations. We can now solve for the Ka. Diba? So Ka is 10 raised to negative 4 times 10 raised to negative 4 divided by 0.7 minus 10 raised to negative 4. Plug in nyo na lang sa calcio yan. 10 negative 4 square 0.7 minus 10 raised to negative 4. So our Ka is 1.43 times 10 raised to negative 8. O, di ba? Kaya. Kaya siya sagutan as long as you double check the question. Asan dyan yung may equilibrium amounts? If given na yung pH, alam mo yun Alam nyo na ito yun. Pag nakita nyo pH, convert mo lang yan to antilog. You will get the X value na. Ganun lang siya ka-easy. Alam nyo na yung pH. Alam nyo na yung H+. Ganun. Okay? And from the X value, from your pH, same na yon as dito. And yung X dito, same yun as the 10 raised to negative 4. Then lahat ng ito, pa-plug in mo sa K-expression, you get the final answer. Tapos na. How about the percent ionization? So again, percent ionization, percent I na lang. That's the concentration of H plus at equilibrium divided by the concentration of your acid times 100%. That will be 10 raised to negative 4 divided by initial concentration ng acid, 0.7 times 100. So the percent ionization is masyadong maliit lang. So that's 0.014%. Okay? Ayan. At other clues pa. Ano pa ang mga pwede magbigay sa inyo ng idea about the equilibrium amounts? Kung hindi pH ang binigay, pwede ibigay yung pOH. So from pOH, you convert that to pH, then yung pH, you convert mo to H+. Ano pa? Pwede ibigay din yung percent ionization. Kunwari, calculate the Ka if the concentration of acid is this, and the ionization is, let's say, 5%. So meaning nun, 5% ng original amount mo, yun ang equilibrium concentration ng acid mo. Okay? So ganun lang. Again, pwede ibigay sa inyo pH, pOH, o kaya percent ionization. Pag percent ionization, all you have to do is to multiply that percent ionization by your initial concentration. You will get the equilibrium concentration of your acid. Multiply mo lang, 5% times this. O, yun na yung X mo doon. And since alam mo na yung X dito, pwede mo na ma-solve yung ibang species. Okay? So you always check kung ano yung relationship ng numbers sa ating problem. They are all related kasi. Diba? Ang saya. Tapos pagdating ng quiz, bulaga na. Madali lang to. Okay, so we're done with the calculation technique. So let's proceed with the other topics. So let's try to see the correlation of your acid and the conjugate base reactions, or the base and the conjugate acid reaction. Okay? So tingnan natin yung relationship ng conjugate acid and base pair natin. So suppose we have this acid, arbitrary acid HA. The ionization reaction for this can be written as HA in equilibrium with H plus and A minus. Ito yung conjugate base natin. What if yung conjugate base natin, siya yung magre-react, no? So, let's say siya yung magre-react with water. So, ito yung reaction niya. Okay, so ano yung pinakita natin dito? Yung reaction ng acid and the reaction of the conjugate base. So, since basic yung property nito, we have the Kb for this one. No? So, yan. If we combine the two equations, we can see that the arbitrary acids will cancel out and the conjugate base will cancel out, no? Giving us the ionization equation for water. So that means, if you have your Ka, you multiply it with your Kb, you will get the Kw. Okay? So, ano lang yung pinakakwento dito? Yung product ng acid dissociation constant and ng base dissociation constant, that is equal to Kw, the ionization product of water, which is 1 times 10 raised to negative 14. Because there will be problems, no? Sa worksheet ko na lang ilalagay. Kunwari, I have this reaction here, HA. Tapos ang ibibigay ko, Kb, hindi siya typo. Kunwari, Kb talaga yung nakalagay dyan, tapos hindi ko siya kinorek. Sinabi ko, hindi yan typo. So, ano ba kailangan mo? Since acid reaction to, di ba, kailangan Ka meron ka. Kaso, binigay ko Kb. So, for you to get Ka, that is just Kw over Kb. So, dito yung galing. Kung gusto mo hanapin yung Ka, just divide both sides by Kb, you will get this equation. Okay, so again, kunwari you have the acid equation, but I gave you the base, Kb, the base constant. Para makuha nyo yung acid constant, you just use this relationship. Ka times Kb equals Kw. Okay, so ganun lang. Ayun na yun. Next one. So, as you can notice, no, yung ating mga problems earlier, it only involves monoprotic acids. No? So, when you say monoprotic acid, those acids only produce one H plus. No? Isang H plus lang yung kinukuha natin parate. But, keep in mind that there are other types of acid, no, other than the monoprotic acid. We have the diprotic acid and the triprotic acid. No? So, diprotic acid meaning dalawa yung H niya. Triprotic meaning tatlo yung H niya. So, paano naman yung equilibrium calculation doon? Okay, so ganito. Our diprotic and triprotic acids can yield more than one H. No? So, pag diprotic, dalawang H mapoproduce nila. Pag triprotic, tatlong H plus mapoproduce nila. However, the ionization of diprotic and triprotic acids are stepwise in manner. Okay? So, when you say stepwise, isa-isa yung pagbaklas ng H. Suppose you have H2SO4. So the first ionization will remove only one H plus. No? So paano yung isa pang H? No? You start with your conjugate base. So this time, yung conjugate base mo naman, magi-give off din siya ng H. No? So yan. So mapansin nyo, the ionization of sulfuric acid is stepwise. Isa-isa lang. So una, matatanggal isang H. Then susunod, yung matatanggal is yung other H from the conjugate base ng acid. Okay? So for triprotic acid, edi tatlong steps yan. So let's say we have phosphoric acid. The first dissociation will give us H2PO4. So after nyan, ito na yung mag-act as acid natin. So it will give off another H plus, and we will get biphosphate ion. May isa pa tayong H. So pwede pa natin baklasin yon for the last time. That will give us the phosphate ion. Okay. So again, for diprotic and triprotic acids, the dissociation of H is stepwise. So they dissociate one H at a time. No? So isa-isa lang siya. So ano yung consequence nun? The consequence is that there are multiple K values for one acid. No? Suppose we have the carbonic acid here, written below. So dalawa yung K values niya na magkaiba yung value. Okay. So there is a K value for the H2CO3, HCO3, and there's also another K value for the HCO3 and the CO3 reaction. Okay? So magkaiba sila ng value. So for phosphoric acid, ganun din. So there is a corresponding K value for this, and for this. Paano kung magsasolve kayo ng equilibrium concentration? You have to do it multiple times. Okay? Siguro isip nyo, ano ba yan? So, yun. You have to use the ice table multiple times, no? If you happen to have diprotic and triprotic acids. But, that will be discussed on the next chapter, no? Chapter 5, which is on the titration. Next chapter na lang yan. So, ang focus lang natin ngayon ay monoprotic acids, no? So, pero next chapter, ayan, didiscuss na natin to. How to do multiple ice table calculations. No? Kaya nga important yung small x approximation. Because if you can do that, then hindi mo na kailangan mahirapan sa ice table. So there will be instances na 3 beses ka maggaganon. Such as this one. Okay? So, ayan. So here are some ionization constants for our acids. No? Take note that sulfuric acid H2SO4, its first dissociation is 100%. No? Strong electrolyte to, H2SO4 for the first ionization. However, for its second ionization, hindi na siya strong. Weak na siya. So you have to employ ice table dito. Pero in sa first ionization, you can use stoic na lang kasi full yung dissociation niya. Sabi dyan, Ka is very large. Ibig sabihin, 100% ionized yan. Pero for the second ionization, only partial amounts yung magdi-dissociate. Here are some examples. Oxalic acid. Ito, pampaputi yan. Yan din ay isa sa mga components ng kidney stones. No? So you have your oxalic acid. Yan yung crystals. Pag lumaki, bato na siya. No? So, yan. So, since may dalawa tayong H, ito, pati ayon, 2 beses siya pwede matanggal. Sulfurous acid, H2SO3, 2 rin, 2 steps. Carbonic acid, 2 steps din. Hydrosulfuric acid, 2 steps din. And for the phosphoric acid, 3 steps. Kasi 3 yung H natin. Don't worry, hanggang 3 lang yung limit. Walang tetraprotic acid. Walang ganun. So, ganun na. So, again, para sa next chapter, next week, no? Alamin nyo na lang na multiple dissociation gagawin natin or multiple ice tables kapag diprotic and triprotic acids. Okay? So, yan. Discuss natin yan sa titration na lang. Let's proceed sa last part ng discussion today. And let's talk about buffer solutions. Okay. So, let's talk about buffers. So, what are buffers? No? Buffers are solutions that resist the change in the pH, no? Upon the addition of small amounts of acids or bases. No? So suppose yung ating katawan, walang buffer. Kasi sandamukal yung buffer system sa atin. Our blood, our cell, lahat yan. May buffer system yan. Imagine nyo wala. No? Tingnan natin, inom tayo ng onting sinigang. Di ba maasim yun? Maasim yun. So ibig sabihin mataas yung H plus concentration doon. No? So ibig sabihin kapag ininom natin yung sinigang, tas wala tayong buffer system sa katawan, patay agad tayo. Bakit? Because at different pH, our proteins may denaturize, no? Pwede siyang masira. Tignan mo yung egg white, di ba? Yung egg white, lagyan mo ng acid, no? Pusa mo ng suka, biglang magbabago itsura nun. Kasi nasira na yung protein structure nun. No? At different pH, our proteins may be destroyed na. So, ganun. Imagine nyo yung body natin walang buffer. So, that means, onting amounts ng acid lang or base sa ating food that can kill us. No? However, that's not the case because our body has buffer systems. No? So, buffer systems, ginagawa nila, they maintain the pH, no, of the body. So, as much as possible, they try to maintain the pH 7.4 for the blood, no. Para kunwari uminom ka ng suka, wala lang, gusto mo lang sinigang, no. Hindi ka hindi mamamatay yung cells mo. Okay? So, yun yung buffer systems. Saan gawa yung buffers? Okay. Ang buffer, gawa yan sa mixture of weak acid and its salt o kaya weak base and its salt, no? So, gawa siya sa, gawa siya sa weak acid and yung salt nun, or pwede rin sa weak base and its salt, no? So, ito yung isang example. We have the sodium acetate and the acetic acid. Yung acetic acid, yung weak acid natin. Sodium acetate, ito yung salt, no? So, ano yung relationship na tong dalawa ng weak acid and yung salt, no? Ganito yung relationship nila. Yung weak acid natin, ito yung acid, syempre, ito yung source ng acid. But our salt is the source of the conjugate base, no? So, kailangan sa buffer system, you have an acid and a conjugate base, o kaya you have a base and a conjugate acid. Yung conjugate acid or base, they usually come in salt form, no? For example, sodium acetate. Ayan. So, ganun. You have weak acid and the salt, no, that contains the conjugate base. Okay? So, ganun. So, if we write the equilibrium constant for the acid, HA, that can be written as this. If we rearrange this equation to get the concentration of H, ganito yung makukuha natin. We obtain the negative log of this equation. No, kunin mo yung negative log ng both sides. So if you get the negative log, so you have the negative log H plus, and yung product dito, mag-split sila into 2, di ba? Sabi ko last time. So that will be the negative log Ka minus the log of the quotient. Okay? So ganun. Yung quotient, magkasama yan. No? Pero yung product, maghihiwalay sila. And what's negative log of H plus? That corresponds to pH. The negative log of Ka corresponds to the pKa, no? Or the negative log of Ka. So, this equation is now called the Henderson-Hasselbach equation. What this equation tells us is ganito. Basta alam mo yung amounts ng acid mo at ng kanyang conjugate base, you can determine the pH of your buffer. No? Pwede mo malaman kung ano yung magiging pH ng buffer mo. So, saan to ginagamit? No? So, we use this, no? Especially sa mga biology class. No? Sa chemistry, di namin to masyado ginagamit. No? But for example, sa medtech, you are cultivating bacteria or cultivating enzyme, you have to maintain certain pH, no, to optimize their activities, no. So para ma-keep mo sila as buhay, you have to create buffer solutions. Para gumawa kayo ng buffer solution, kailangan you have the correct amount of your acid and your conjugate base. Paghahaluin mo lang yung dalawang yon, usually naka-sachet yon. So, pag pinaghalo mo yon, you will have your buffer solution na. So, yun. Yung friend ko kasi nag-thesis nung undergrad about enzymes, no? Enzyme catalysis. So, yun. So, nakikita ko sila, they create buffers. Bakit? Kasi yung enzyme nila, Pwedeng masira at different pH, no? So, para optimum yung ano nila, activity. So, kailangan may certain pH silang i-control. So, they create buffer solutions. Okay? So, sa medtech, gagawin nyo din yan, no? Sa higher subjects nyo. I don't think kung clinical chem ba yun or what, no? So, gagawa din kayo ng mga buffer solutions. Okay? So, again, buffer solutions are mixture of acid and its conjugate base, o kaya base and its conjugate acid. Okay, and we can use the Henderson-Hasselbach equation to determine kung ano yung pH na magagawa natin given the quantity of your acid and the conjugate base. No? Another form of the Henderson-Hasselbach equation ay positive itong nasa gitna. Kasi baka isipin nyo, nasa textbook pa si sir, positive to. Tapos baliktad to. Same lang ba yun? Same lang. Okay. So, pakita ko yung other versions ng Henderson-Hasselbach. So, the other version is positive to because reciprocated ito. Nasa property kasi yun ng logarithm. When you flip the fraction, magpapalit ng sign yung log. Di ba? Puro math. So, this is one form of the Henderson-Hasselbach. The two are equal. Same lang yan. Properties ng log lang yung ginamit natin. Kaya we were able to get this. Same lang yan. And the counterpart of this Henderson-Hasselbach equation is yung POH naman. So, ano yung counterpart ng pH? Yan ay POH. Ano yung counterpart ng pKa? Ano yung counterpart ng Ka? Di Kb. O, kunin mo negative log ng Kb. You get pKb. Okay? Plus log. Ano yung counterpart ng conjugate base? Di conjugate acid. So, we write the conjugate acid as BH+. And ano yung counterpart ng acid? That's the base. We write it as letter B lang. So, ito yung three forms of Henderson-Hasselbach equation. The one is the typical. Ito yung counterpart nun. Yung negative log, ginawa lang positive by flipping the fraction. So, same lang doon dalawa. And then the other one is if you have base, no? Kunwari may base ka sa solution mo. Ito yung equation na gagamitin mo. Ito ginagamit to kapag acidic. Pero kapag basic, ito yung gamit mo. Okay? So take note that the counterpart of pH is POH. The counterpart of pKa is pKb. The counterpart of conjugate base is conjugate acid, denoted as BH+. The counterpart of acid is the base. Binaliktad lang natin yung roles nila in terms of the base. Okay? So, ibig sabihin, kailangan alam nyo kung acid yung substance nyo or base. Because depending on their identity, pwedeng magkaiba, pwedeng ito gamitin mo or ito. Okay? Ito, hindi natin kailangan ng ice table dito. So, tanong dito, what is the pH of a solution containing 0.30 molar formic acid and 0.52 molar potassium formate? Okay, so ano daw yung pH ng solution that contains 0.30 molar formic acid and 0.52 molar potassium formate? Okay. So, nasabi ko kanina, a buffer is a solution of the acid and its conjugate base in the form of salt, no? Ito yung conjugate base in the form of salt, no? So, instead of having H, no, papalitan mo lang yon ng potassium, sodium, lithium, no? So, yun na yung salt na sinasabi ko. So, this is the formic acid. This is the potassium formate, the source of the conjugate base. No? So, alam na natin yung concentration ng acid. Alam na natin yung concentration ng conjugate base. We can use the Henderson-Hasselbach equation to determine the pH of the solution of the mixture. So we write pH equals pKa plus log ng conjugate acid, conjugate base divided by the acid. pH. Ano yung pKa? The pKa pertains to the negative logarithm of your dissociation constant for the acid. So, ano yan? Nasa table yan. Di ba last time may pinakita akong table? Andun yan. So, hindi yan kakabisaduhin. Tinitignan yan. So, for the acid, hanapin natin yung Ka ng formic acid. So, ito yan. Ayan. So, ito yung formic acid. Ito yung Ka niya. Ayan yung Ka na gagamitin natin doon. 1.7 times 10 raised to negative 4. Okay? So for formic acid, Ka is 1.7 times 10 raised to negative 4. To get the pKa, that is the negative log of Ka. Now negative log 1.7 times 10 raised to negative 4. We say pKa is equal to 3.77. So pKa is 3.77 for the formic acid plus logarithm of the concentration of conjugate base over the acid. Ano concentration ng conjugate base? No? 0.52. Ano yung concentration ng acid? 0.30. So let's now solve for the pH of this solution, of this buffer solution. So the pH of this buffer solution is 4.0. Ayan, so suppose your enzyme works at pH 4. You have to create a buffer solution at pH 4. So gagawin mo, magtitimpla ka ng 0.3 molar formic acid and magpe-prepare ka ng 0.52 molar ng potassium formate. Then pagsasamahin mo lang sila. So pag pinagsama mo yon, yung pH niya exactly 4. Okay? So ganun ginagawa dyan. So ganun lang calculation. No more ice table na pag buffer. Although pwede rin naman, pero hindi na necessary. Okay? So ganun lang. So again, kailan mo malalaman kung gagamitin mo yung Henderson-Hasselbach equation? Ang una nyong gagawin is to check whether you have an acid and a conjugate base. So ano yung difference nila? Just look at the formula. Yung isang H doon mapapalitan ng metal. Usually potassium, sodium. Okay, so yun lang. Usually sodium or potassium ang gamit na metal. Okay, so once na na-determine mo na ito yung acid, ito yung conjugate base, palagin mo na lang yung concentrations nila sa Henderson-Hasselbach equation. And this is the pH of your buffer. Okay, so in this graph, we can see that suppose we have a water lang and the buffer solution. Tignan nyo yung graph, no? If we add acid sa ating water, look at what happens sa pH. Drastic yung change, no? So imagine nyo kung yung katawan natin puro tubig lang talaga, as in wala nang buffer system. Uminom lang tayo ng suka, patay agad tayo. Patay na yung cells natin. Kasi ang pH ng blood, 7.4. Uminom ka lang ng onting suka. Bagsak agad yung pH mo. Okay? So, ganun. Pero, with the help of the buffer, Ano nangyayari? Basta mag-add ka ng acid, the pH is somehow maintained, no? May onting variation pero not that much, no? Hindi ganun kalaki yung changes sa pH. Ayan. So, yun yung importance ng buffer. So that when you add acid or bases, your amounts don't change. Wait lang, may call. Sagutin ko lang. Okay, anyway. So, may call lang from the bank. Anyway, so ano lang to? So, yan. Kapag buffer system, the pH doesn't change, no? Whether you add acid or base, no? Hindi agad-agad siya nag-change, no? Compare that with the water alone. Okay. So, ito. Let's try to determine if these three mixtures are buffer system. So, tignan natin kung buffer system sila. Again, ano yung relationship ng buffer systems? You have the acid and the conjugate base in the form of salt, no? Usually, yung H napapalitan ng metals lang. K or Na, no? So, ganun. So, tignan natin. Maglalagay pa akong isang item. Letter D. Okay, so yan. So, let's try letter A muna. Is letter A buffer system? Tignan natin. So, KF and then HF. Let's try to see their relationships. Obviously, yung HF acid yan. Halata naman eh. H yung kanyang cation. So, acid yan. How about KF? Okay, dissociate natin to into 2. Kasi ito yung salt na sinasabi ko. We can get K plus and F minus. O yung metal ion, wag nyo napansinin yan. Wag nyo napansinin yan. Just focus on the anion. Is this related to this? Related ba sila sa isa't isa? Ang sagot natin dyan ay, yes, they are related, no? Bakit sila related? Kasi the only difference is that isa lang yung H na kulang sa F minus. So that means, kung ito yung acid, this must be the conjugate base, no? Again, paano natin nalaman na ito yung conjugate base? Kasi isang H lang yung difference. Yung H na palitan ng metal. Okay? So this is our conjugate base. And then we have an acid. So that means this letter A is a buffer system. It's a buffer of hydrofluoric acid and fluoride ion as the conjugate base. Okay, so ganun gagawin nyo when checking for buffer systems. Alamin nyo yung sino acid, yun yung usually may H. And tignan nyo kung may conjugate base siyang kasama. So if you have a salt, split mo yon into cation and then ion. Then from that, tignan mo kung may relationship yung anion sa acid. If one hydrogen lang yung difference nila, buffer system yan. Kasi conjugate base ito ng acid. Pero kapag more than one yung hydrogen na kulang, more than one H yung difference nila, hindi yan buffer system. Okay? So we're safe to say that letter A is a buffer system of hydrofluoric acid and fluoride ions. Let's have letter B. For letter B, we have potassium bromide and HBr. Obviously, yung HBr, ito na yung acid natin. How about KBr? You split that into ions. No? So, meron tayong K plus and Br minus. Disregard your metal, focus on the anion. Are the two related? Related ba sila? Yes, they are related. Why? Bakit natin nasabing related sila? The difference is isang H lang. Okay, so since isang H lang yung difference nila, they are conjugate acid-base pair. Okay? So pair sila. So HBr is the acid, Br minus is the conjugate base. So we are also safe to say that this one is a buffer system. You have the acid, HBr, and you have the conjugate base, the Br minus from potassium bromide. Buffer yun. How about letter C? So for letter C, we have sodium carbonate and sodium bicarbonate. Sa case na to, hindi obvious. Sino yung acid dyan? Hindi obvious. So gagawin mo, yung mga metals mo, buburahin natin. Okay? So we have sodium carbonate. You have sodium bicarbonate. Parehas yung ionic compound. So split mo sila into two. Yung mga metals and yung anions. Basi this time, alam nyo na dapat yung charges, ha? So if you have both ionic compounds, split mo sila into ions and disregard the metals. Burahin mo yung mga metals. So tingnan mo yung mga natirang ions mo. Are the two ions related? So they are also related. Bakit? Ano yung difference nila? Isang H lang. Okay? So itong HCO3 and CO3, they are related. Kasi isang H lang pagitan nila. So that means yung may H, ito yung magiging acid natin. Itong CO3, ito yung magiging conjugate base. So we can say that this is a buffer system also. So ano napapansin nyo sa pinagagawa natin? Yung difference lang nila sa H ay isa. Basta isa lang yung H difference nila, buffer yon. So for letter C, that is another buffer system. How about letter D? Okay. How about letter D? Buffer system kaya ito? Obvious naman, yung H3PO4, this will be our acid. Tapos ito yung salt. Tignan natin kung anong ions magagawa natin dyan. Okay. So, we can get sodium ion and phosphate ion. Wag pansinin yung sodium. Wag pansinin yung metal. Just focus on the anion. Are the two related? When I say related, isang H lang ba difference nila? So, obviously, hindi. No? Ilang H pagitan nila? Tatlo. Okay. So, since you have more than one hydrogen difference, ibig sabihin, hindi to buffer. Okay. So, bakit? Hindi siya buffer. Kasi, when we say buffer, we must have an acid and its conjugate base. No? Ang conjugate base ay one hydrogen less than your acid. Okay lang sana kung ito ay H2PO4. Buffer yan. But ang meron tayo ay PO4 minus 3. No? Phosphate lang meron tayo. So, kulang siya ng tatlong hydrogen. So, that means the two are not related. Hindi sila conjugate acid-base pair. Ibig sabihin, hindi yan buffer system. Okay? So, again, not a buffer. So again, for us to judge kung sila ay buffer system, just look at your ions if one hydrogen less siya sa acid. Kapag 1 hydrogen less than yan sa acid, yan ay buffer system. Okay? So, ganun lang. Ganun din sa bases, no? Sa bases naman, tignan mo kung isang hydrogen lang din yung pagitan nila. Kasi kapag more than one, hindi sila related at all. Magkaibang equilibrium expressions yung relationship nila. So, hindi sila magka-tandem. No? So, ganun lang po. So, siguro may items na ganito sa ating quiz. I will show you different salts and you will distinguish which among them ang buffer or not. Okay? So, mamimili kayo. Sino doon yung buffer or hindi. Ano yung technique? Yung mga metals, burahin mo. Tignan mo kung ano yung ions na natira sa'yo. If ang difference lang nila ay isang hydrogen, such as this one, and this one, buffer system yun. But if the difference of hydrogen is more than one, hindi yun buffer system. You cannot use the Henderson-Hasselbach equation for that. Okay? Let's try this problem. Last one na to for our session today. After this, tapos na yung ating class. So, let's have number 1. Calculate the pH of the 0.3 molar ammonia, 0.36 molar ammonium chloride buffer system. What is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? Okay. So, ang question, is ammonia and ammonium chloride a buffer system? Are they related? The answer is yes. Ano meron tayo? We have a base, NH3, and yung kanyang conjugate acid ay yung ammonium ion. Disregard the chloride. No? Kapag base, isang H lang din pagitan. So we have a base and a conjugate acid. So since we have a base and a conjugate acid pair, yan ay buffer system. So anong equation gagamitin natin dito kapag may buffer system tayo? We have to use the Henderson-Hasselbach equation. But since base ang meron tayo, we will use the other version of the Henderson-Hasselbach equation. When yung POH equals PKB plus log conjugate acid divided by the base. Okay? Bakit ito yung equation na ginamit natin, hindi yung pH equals pKa plus log A over HA? Bakit ganun? Kasi, ang meron tayo ay base, no? Gagamitin mo lang yung pH equals pKa something something kapag acid ang meron ka. And base yung meron tayo eh. So, we need to use this equation. So, yan. So, lagay natin yung answers. POH. Ano yung PKB? That's the negative log of your KB. Ano yung negative log ng KB? Sulat ko muna to. Ano yung KB for ammonia? Hindi ko kabisado yan. Titingin tayo sa table. Asan ba yun? Ito. So, ito yung KB. Listahan ng KB natin. Hanapin si ammonia. Okay. Ayun. So, we have ammonia. Oopsie. So, we have ammonia. That's 1.8 times 10 raised to negative 5. Same as acetic acid siya, no? Pero KB. So, ipa-plug in natin yung KB na yan doon sa ating Henderson-Hasselbach equation. Plus the logarithm of the concentration of the conjugate acid. Ano yung concentration ng conjugate acid? 0.36. How about the base? 0.30. So our POH is equal to, solve na lang. So that's equal to 4.82. If you convert that to pH, that is equal to it's equal to 9.18. So the pH of our buffer system is 9.18. Okay. So that's the answer for the first sentence. What happened sa second sentence? Sabi, what is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? Ano daw yung magiging pH when we add sodium hydroxide sa solution natin? O, isip tayo. What is sodium hydroxide? Ang sodium hydroxide ay base. So that means when we add base to our buffer, madadagdagan yung concentration ng base natin and mababawasan yung concentration ng conjugate acid. Okay? So again, ano nangyari? Pag naglagay tayo ng base sa solution natin, the concentration of your base will increase while the concentration of your conjugate acid will decrease. Okay? So, madadagdagan itong ating base, mababawasan ang ating conjugate acid. Paano naman? Kunwari, nagdagdag ako ng acid. Tataas yung concentration ng conjugate acid, mababawasan yung concentration ng base. Okay, so counterpart parate. Pag naglagay ka ng base, tataas yung base, bababa yung acid. Pag naglagay ng acid, tataas yung acid, bababa yung base. So that means, etong nasa log function natin, babaguhin natin to. Ito lang yung babaguhin natin. The rest will remain the same. So itong log lang yung magbabago, ha? So that means ika-copy ko lang ulit to. So let me copy that. Itong pKa is, lagay ko na lang siya as 2 decimal places. So that's 4.74 plus log ng conjugate base and the conjugate acid. Ay, ng conjugate acid and the base pala. So remember kanina, the conjugate acid is 0.36, the base is 0.30. Basahin natin nangyari sa problem. Naglagay tayo ng 20 ml of 0.05 molar ng base, no? So we added 20 ml of 0.05 molar base. So ibig sabihin niya, madadagdagan yung ating base at mababawasan yung ating acid. Pero, imagine, tignan nyo, 20 ml yung dinagdag natin, ha? Yung ating buffer solution kanina, 80 ml daw. So what will happen when we add 20 ml of solution sa 80 ml solution? Tataas yung volume niya. Okay? Magi-increase yung volume. Therefore, madidilute lahat ng ating concentrations. Madidilute itong 0.36, madidilute itong 0.30. Tapos kung ano man to, madidilute din yan. Okay? So that means we have to solve for the new concentrations, including the additional factors, no? Itong additional na base, no? So alamin natin yung bagong concentration ng ating conjugate acid-base pair, no? So alamin natin kanilang new concentrations. Originally 80 ml sila, ngayon 100 ml na. Because 20 ml yung dinagdag natin sa 80 ml. So gamitan lang natin to ng C1, ng M1 V1 equals M2 V2. No? So let's use the dilution formula to get the new concentration of our conjugate acid and the base. No? So alamin natin yung dito. Dito na lang sa baba. The new concentration of the base, no? Itong 0.30, M1 V1 equals M2 V2 yan. So alamin natin yung M2. M2 is equal to M1 V1. So 0.30 molar times 80 ml divided by the new volume, 100 ml. So that will be the new concentration of your base. Which is 0.24. Ito na yung new concentration ng base natin. Because of the dilution, naglagay tayo ng additional solution eh. So magbabago yung concentration niya. Okay? Let me erase this. Ay, hindi siya nabubura. So the new concentration of the base, no, is 0.24 molar. Hindi pa natin tinitake into account yung additional amounts of base, no. Yung yung meron lang tayong existing. In-adjust lang natin yung kanyang concentration. So hindi pa natin dinadagdag dito yung sa sodium hydroxide, no. So our base will now be 0.24 molar plus kung ano man itong concentration na to. Okay, so kunin natin. So we have 20 ml of 0.05 molar. Tapos nilagay yan sa 100 ml solution na. So that will be 20 ml times 0.05 molar divided by 100 ml. Puro dilution formula lang gamit ko plus 0.01. So ito na yung additional base, no? Ito yung madadagdag sa ating existing base. Bumaba lang yung number because of dilution. Bumaba lang yung number. 'Di ba kanina 0.30 to? Ngayon 0.24 na lang kasi na-dilute siya when we add this amount of the base, no? So ito na rin yung concentration ng base na to sa solution. We use the dilution formula. How about the conjugate acid? So yung conjugate acid natin, originally that's 0.36 molar. So our conjugate acid is 0.36 molar. Alamin natin yung new concentration at 100 ml. That will be 80 ml, yan yung original. Tapos ngayon, naging 100 ml na siya. So the new concentration is 0.288. But mababawasan pa yan. Bakit mababawasan? Kasi naglagay tayo ng di ba? Ng base. So yung base madadagdagan ng 0.01 molar. Yung acid mababawasan ng 0.01 molar. Okay? So kung gaano karami nadagdag sa base, ganon din karami yung mababawas sa conjugate acid. Okay? So ganon lang. So gagawin nyo, basically i-adjust nyo ito, pati ito. I-adjust mo lang yung kanilang concentrations. And then, yung molarity ng dinagdag mong solution, plus yan for the base, minus for the conjugate acid. No? Kasi base itong dinagdag mo. So, plus dito sa baba, minus sa taas. Same number lang. So, with that info, i-plug in na natin to lahat sa calculator. We have 4.74 plus log ng 0.288 minus 0.01 divided by 0.24 plus 0.01. What will be the resulting POH? 4.74 plus log so the resulting POH is 4.79. Okay, so the resulting POH is 4.79. So the pH value is now equal to 9.21. Okay, so this is the new pH value, 9.21. So by just adding this amount of base, nag-adjust yung pH natin. But not so drastic, no? Hindi ganun kalaki yung change. Onti lang. Because of the buffer. Pag walang buffer yan, yung pH natin, malaki yung change niyan, no? Okay? So, yan. So, malaki magiging change nila. But because of the buffer system, onti lang yung naging difference nila. Even though you added a base, no? By the way, since parang siguro alam ko yung reaction nyo dito, parang ang complicated naman yan. No? Yes, complicated to. Tsaka, actually, sa next chapter pa talaga to. Dinaanan ko lang today so that may insight na kayo kung ano yung itsura ng next chapter natin after the midterm period. So, the next chapter will focus on the titrations. In titration, we maximize the use of the Henderson-Hasselbach equation. Gamit na gamit itong formula na to. So I want you as early as now to be familiar with how we use the equations. Then take note na kapag nagbago yung volume ng solution, you have to adjust all the concentrations. Atong point 36, i-adjust mo yung concentration to the new volume. Ang new volume natin ay 20 ml plus 80 ml. So we get this. Atong point 30, adjust mo yan to your new volume. So we get 0.24 molar. Then plus minus kung ano yung dinagdag mong species. Kapag base yan, idadagdag mo yan sa base. Kapag acid yan, idadagdag mo yan sa acid. So I want you to be familiar with this, although more problems about this will be seen sa next chapter na lang. Maglalagay ako ng onting ganito sa sa quiz and sa worksheet, pero yung basic lang. Especially ito lang. Hanggang dito lang yung ibibigay ko mostly. Although magbibigay ako ng onting item na may ganito, I will show the solution there. Okay, mas marami kayong examples. Pero mostly na makikita nyo sa quiz, ganito lang. You have the concentration of this that determine the pH. Tapos sa worksheets, maglalagay ako doon na what if naglagay ka ng ganito? What will happen to the pH? No? So yan. So I want you to be familiar na about this. Yes, medyo mahirap yan. No? Struggle ko rin yan during undergrad, but kaya naman yan, kakayanin yan. As long as you always remember to use dilution formula. No? Kasi kapag nag-add ka ng volume nito, madidilute yung species mo. So, i-adjust mo yung mga concentrations. Yun yung ginawa ko kanina dito. Okay, so yan. So, I think application ng buffer in our cells, especially the red blood cell, the pH of the blood is 7.4, no? Slightly alkaline siya, okay? Because of the presence of the phosphates, no, in there. Actually, maraming buffer systems daw. We have the phosphate and the carbonate buffers. Okay? So ito, yung pinapakita dito, we have the carbonate buffer. Carbonate buffer is the primary reason why blood can transport oxygen and carbon dioxide. Yung ating blood, that is a protein. Yung hemoglobin, protein yan. Okay? So it can trap or release oxygen and carbon dioxide gas. No? So yan. And more of this sa biochem na. Sa biochem na and sa clinical chem. No? Pinapakita dyan, ito yung taut state and yung relaxed state ng ating blood cells. Sasabihin dyan ng prof nyo na at relaxed state, yung ating blood, they will carry oxygen. At taut state, ang i-release niya, CO2, etc. Okay, so ganun. Basta yan lang. So one example of the buffer system sa ating body ay yung carbonate system, carbonate buffer. And also yung phosphate buffer. Okay? So medyo maraming math na involved, no? So ano lang, don't worry, ano. Mas marami pa kayong makikitang ganitong example next chapter. Although I will include some of this sa ating worksheet pati quiz para ma-practicean nyo na. Okay. Para pagdating ng titration, master nyo na. Sa titration, gamit na gamit yung square root of tsaka, pati itong buffer na to. So, yun lang yung mga gagamitin nating equations. Okay? So, with that, we are done for the coverage of our topic today. So, natapos natin to. Hindi siya naka-full screen. So, natapos na natin ito. Square root of tsaka. Itong diprotic, triprotic acids. Alam nyo na that stepwise yung ionization ng acids. Buffer solution, you remember the forms of the Henderson-Hasselbach and how to perform basic calculations with it. On Monday, we will continue with the last two topics. Mabilis lang yan. The solubility, equilibria, and the common ion effect and the solubility. Okay? So, yan. By the way, no, I'm thinking of having this topic as a synchronous topic. No? So, tignan ko na lang kung ano mangyayari. No? Kasi sa aking lecture class, yung next week namin, mag-ano lang kami, asynchronous kami nun. Kasi para may time sila to review. Kasi ano lang kami, 2 hours every week eh. But in your case, 6 hours tayo kada week. Tignan ko, kapag kinaya ko makapag-record nito sa weekends. Okay. So this could be asynchronous or pwede rin naman synchronous. No? So update ko na lang kayo about that. Okay, so that will be all. By the way, just a short remember ulit. The quiz 1 will cover these topics. Quiz 2 will cover these topics. No? Quiz 4 part 1 pala. Ito yung topic niya. Quiz 4 part 2. Ito yung topics niya. Okay. So ito, na-discuss na natin to last week, Monday. So you can actually start with this na. For the quiz 4 part 2, ito yung discuss natin ngayon pati sa Monday. So you still have more time. Kailan mag-open yung quiz 4 part 1? That will be open starting Monday to Wednesday next week. And yung quiz 4 part 2, that will open by Thursday to Saturday next week. I will upload a worksheet for this chapter and additional problems pa. Okay? So hopefully makatulong yun sa review nyo. Okay, so yan. That will be all for our session today. If you have any clarification, don't hesitate to message me right away. Okay? Nagre-reply naman ako kahit gabi. Okay. So yan. So I'll see you again on Monday, no? Maybe. So kita-kits na lang. For now, enjoy your other classes. I'll see you again next time. Bye-bye, and a copy of the recording will be uploaded on YouTube. Okay, so thank you and good luck.